Imagine a mountain-sized asteroid hurtling through space, set to pass closer to Earth than many satellites in just a few short years. The world holds its breath, not because we expect it to strike, but because it's handing us a once-in-a-lifetime chance. The asteroid's name is Apophis, and the countdown to its historic flyby in April 2029 has already begun. Yet while scientists around the globe sound the alarm to seize this cosmic opportunity, NASA finds itself at a crossroads. Will budget shortfalls and indecision cause us to squander our chance to unlock the secrets of one of Earth's most infamous visitors? Why does this matter? Because what we learn from Apophis could shape the very future of planetary defense, and perhaps the fate of our civilization, should a true impact threat ever emerge. But first, we have to act. Time is running dangerously short. If you've ever wondered how government budgets, international rivalry, and technological ambition collide in the domain of space, and what's at stake for humanity, this is the story you cannot afford to miss. Let's rewind for a moment. Apophis isn't just a rock in the void. Discovered in 2004, it quickly shot to global infamy because initial calculations suggested a real, if small, chance of a catastrophic Earth impact in 2029 or 2036. The media ran wild, and for a brief moment, headlines screamed about a potential doomsday scenario. Astronomers jumped into action. As more observations came in, those odds plummeted. It was a near miss, not a direct hit. But the public's fascination never faded, because Apophis marked a wake-up call. We weren't as safe from cosmic hazards as we like to think. Planetary defense, the science and engineering of identifying, tracking, and if necessary, deflecting killer asteroids, was propelled to the center of international discourse almost overnight. Figures like Eugene Shoemaker and Eleanor Helen, who had quietly cataloged asteroids for decades, suddenly found themselves in the spotlight. The Space Guard survey in the 1990s began the systematic hunt for potentially hazardous objects, and new inventions like the Torino scale let experts communicate the meaning of asteroid risk to a wary public. The world's eyes turned skyward. Powerful radar dishes like Arecibo and Goldstone tracked Apophis and its peers, refining orbits, shapes, and sizes. Each discovery was a reminder. The solar system has teeth. Small, unseen asteroids can slip past our planetary skin and pose a real danger. The Tunguska event, the Chelyabinsk meteor, history offered ominous warning shots. But it was Apophis's close shave that galvanized efforts to get serious about this existential threat. Fast forward to today. Apophis is no longer a doomsday object, but it remains one of the most scientifically tantalizing asteroids ever identified. On April 13, 2029, it will shoot past Earth within just 32,000 kilometers, closer than many of our geostationary satellites. This is, in the words of planetary scientist Patrick Michel, a cosmic gift. Why such excitement? Because never before has an asteroid of this size, about 340 meters across, the length of 3 football fields, come this close while being so thoroughly tracked. Its passage offers a chance to test our best planetary defense techniques and probe the mysteries of asteroid behavior under extreme gravitational stress, as Earth's pull is expected to physically reshape Apophis's very surface. That's not science fiction, that's raw, real-time geology, played out in the heavens with cameras and sensors ready. The scientific appetite is enormous. Experts want to know, will Apophis's trajectory subtly shift due to the so-called Yarkovsky effect, where sunlight heats one side of the asteroid more, nudging its path over years? Will its spin speed up or wobble after Earth's tidal grip? Will landslides or quakes scar its surface during the flyby? For planetary defense, these are not idle curiosities. They are critical data points that might someday mean the difference between protecting humanity and facing disaster. But here's where the story gets complicated. Grand plans are easy to dream up. Making them real is another matter entirely. NASA, Europe's ESA, Japan's JAXA, and even startup companies and universities have floated mission concepts to explore Apophis before its flyby. Each has unique technology and scientific goals. In the US, attention has focused on an unlikely hero, 2 small spacecraft called Janus. Built for a different asteroid mission that was scuttled due to launch delays, the Janus twins now sit in storage, pristine, packed with high-tech optical and infrared sensors, and, crucially, ready for rapid redeployment if given the green light. Janus can provide fast flyby science, informing us of Apophis well in advance, says Dan Sheares, a prominent asteroid researcher at the University of Colorado. Pre-flyby data could help scientists plan and interpret the deluge of observations expected after Apophis passes Earth, allowing before and after comparisons that no ground-based telescope could match. The Janus proposal received a surge of support at an international workshop in Tokyo, with researchers pleading for NASA to commit funding and move quickly. But as of now, Janus is still mothballed, victim perhaps to a tangle of budget constraints, bureaucracy, and shifting priorities. NASA's top science official Nikki Fox recently admitted, "We didn't find a viable path forward for a pre-flyby mission without significant budget from us that we actually didn't have." The space agency isn't blind to the stakes. "We're still discussing it," Fox told reporters, "but every month that ticks by closes the window for launch and the clock is unforgiving. By 2026, any mission hoping to catch Apophis must already be built, tested, and en route." The story doesn't end with Janus. NASA's OSIRIS-APEX spacecraft, fresh off a triumphant sample return from asteroid Bennu, has already been reassigned to rendezvous with Apophis after its 2029 flyby. Its job: document how the close brush with Earth may rip apart or resculpt Apophis's surface and spin. The data will be historic, but only a post-game report. As Nikki Fox admits, even though the images are going to be low resolution, we're going to have some really nice images of how the light and the brightness changes. The Europeans are not standing still. ESA's Ramses mission is in the works, slated to arrive before the flyby, if it survives political and funding hurdles this November. Ramses aims to do what Janus cannot: orbit Apophis, and even deploy landers to study its internal structure and chemical makeup. Ramses will provide unprecedented insight into the internal structure and surface properties of a near-Earth asteroid, says Patrick Michel of the French research agency CNRS. That's the upside. The risk is that funding could evaporate, and delays are a constant specter in space science. Japan, too, may join the race. JAXA's Destiny Plus probe, postponed due to rocket issues, could potentially swing by Apophis on its way to study another asteroid, Phaethon. The mission might end up being a scientific bonus round, offering unique data on how solar radiation and cosmic weathering affect asteroid surfaces. As for private enterprise and academic consortia, they've floated miniature probes, CubeSats, and even rapid response flyby missions. But the technical and financial obstacles are enormous. Building, launching, and coordinating an interplanetary probe is the stuff of billion-dollar budgets and Herculean logistics. The 2029 window is so tight that, in the words of one workshop report, time is of the essence for moving forward decisively. Through it all, the international scientific community has spoken with rare unanimity. Delay is not an option. We collectively entreat and emphasize to our respective agencies that time is of the essence, reads the Tokyo Workshop's official plea. If we miss the pre-flyby window, the science is gone forever. So why the gridlock? At its core, the dilemma is a collision of ambition and reality. On the one hand, missions like Janus, Ramses, and Destiny Plus are ready to unlock Apophis's secrets and advance the cause of planetary safety. On the other, they run smack into the hard wall of limited budgets and bureaucratic inertia. NASA's own Lori Glaze notes, "Our budget situation is really challenging, and that is a reality that we have to live within." This isn't just an American story. The 21st century space race is rapidly globalizing. The European Space Agency is staking its claim with Ramses, Japanese engineers offer their technological flair with Destiny Plus, and national pride is entwined with international cooperation. Rusty Schweikart, a former astronaut and one of the world's leading asteroid defense advocates, reminds us, international cooperation is essential for developing effective asteroid deflection strategies. Even so, the odds are daunting. Consider this. The now silent Arecibo Observatory, which was instrumental in refining Apophis's orbit, lies in ruins. Telescopes like the upcoming Vera C. Rubin Observatory promise revolutionary leaps in NEO detection, but can't launch missions. Advanced techniques like kinetic impactors, think NASA's successful DART mission, which nudged a small asteroid in 2022, require years of preparation and a deep understanding of each target's makeup and spin. And then there's the Yarkovsky effect, the tiny, relentless push caused by sunlight heating up an asteroid's surface and radiating energy back into space. It's barely perceptible, but over years or decades, it can steer an asteroid thousands of kilometers off course. As Alan Harris, planetary scientist, points out, the Yarkovsky effect introduces significant uncertainties in long-term asteroid trajectory predictions. That's why close-up observations, especially before Apophis crosses Earth's path, are so crucial for refining future risk estimates. Meanwhile, the risk calculus grows ever more complex. The more we learn about Apophis, the sharper our planetary defense playbook becomes. But indecision and underfunding threaten to leave us flying blind. The stakes transcend science. As Lyndley Johnson, NASA's planetary defense officer, puts it, the objective is to engage the public and private sectors in innovative, low-cost missions during the Earth flyby of Apophis. The hope is that Apophis will be a model for how the world can respond to a potential future threat, knitting together governments, space agencies, corporations, and even citizen scientists. But with every passing month, the window for meaningful pre-flyby science narrows. What happens if political gridlock, budget crises, or technical delays mean none of these missions launch in time? How close are we to losing an opportunity that, in cosmic terms, will not occur again for thousands of years? As the countdown to 2029 continues, we face a question not just of science, but of our collective will, and our readiness to seize fleeting cosmic opportunities before they slip away forever. As the clock ticks toward April 2029, the world's leading space agencies stand at a crossroads. The decisions made in the next 18 months will ripple not just through the halls of NASA, ESA, and JAXA, but through the very future of planetary defense. Let's explore what's really at stake. What happens if humanity rises to the Apophis challenge, or if we blink and miss it altogether? The Apophis flyby is far more than a celestial spectacle. In the best-case scenario, multiple missions, Janus, Ramses, Osiris Apex, and perhaps Japan's Destiny Plus, could converge on Apophis, collecting a treasure trove of data before, during, and after its close brush with Earth. If these probes are successfully launched and coordinated, we could witness, for the first time, the real-time transformation of an asteroid's surface, structure, and rotation under tidal stress from our own planet. Imagine Janus's rapid-fire cameras capturing Apophis as it approaches, imaging its surface in visible and infrared light. Minutes later, ESA's Ramses landers could anchor themselves to the dusty regolith, transmitting seismic and thermographic readings as the asteroid's subsurface trembles under the pull of Earth's gravity. Osiris Apex would arrive soon after, mapping every inch for changes, hunting for landslides and surface fractures with unprecedented detail. And in this cosmic relay, Destiny Plus could, if the timing works, provide a unique perspective on the asteroid's weathering from solar radiation and Earth's tidal forces. The resulting dataset would be historic. Scientists might finally unravel mysteries like the cohesion of asteroid rubble piles, how spin rates and orbits shift during encounters, and whether surface material can be mobilized or ejected by Earth's pull. These insights aren't just scientific curiosity. They are crucial clues on how to deflect a real threat should a future asteroid set its sights on Earth. But here's the darker scenario. If bureaucracy, funding gaps, and indecision win out, our international fleet may be reduced to a single post-flyby observer, Osiris Apex, arriving too late to witness the tidal drama firsthand. Without pre-flyby reconnaissance, we'd have to rely on remote telescopes and ground-based radar. It would be like watching a great play through a keyhole, aware that the main act has just slipped through our fingers. The risk isn't just academic. The science we forfeit may prove critical the next time an asteroid's orbit threatens Earth. The Yarkovsky effect introduces significant uncertainties in long-term asteroid trajectory predictions, notes planetary scientist Alan Harris. If we miss this chance to test our models against a real, massive NEO in deep space, we're gambling with incomplete information the next time the stakes are much higher. There's also the risk of eroding public trust and political will. The Apophis event is visible, almost tangible, for people worldwide. Losing this moment could reinforce cynicism about slow-moving institutions, making it harder to muster resources for planetary defense in the future. As Rusty Schweikart, a leading asteroid deflection advocate, puts it, international cooperation is essential for developing effective asteroid deflection strategies. Missing this chance could set a precedent for costly inaction. Yet there's a third path, one that transcends the binary of success or failure. Even partial victories could teach us valuable lessons about rapid mission development, public-private partnerships, and agile international coordination. Lyndley Johnson, NASA's planetary defense officer, notes, the objective is to engage the public and private sectors in innovative, low-cost missions during the Earth flyby of Apophis. If agencies are forced to improvise with smaller budgets and tighter timelines, it could spark breakthroughs that make future planetary defense faster and more nimble. Looking beyond 2029, the Apophis moment can focus global attention on the broader challenge of asteroid threats. Every year, new NEOs are discovered, some far larger and more menacing than Apophis, thanks to advances like the Vera C. Rubin Observatory and future space-based telescopes like NEO Surveyor. Each detection is a roll of the dice. Most pass safely by, but statistically our planet is due for another major impact. The question isn't if, but when. Take, for example, the lessons from NASA's DART mission, which successfully nudged the tiny moon Dimorphos off course in 2022. That test proved we can push a small object, given years of warning and perfect conditions. But Apophis, at 340 meters across, is an order of magnitude bigger and more complex. How would our kinetic impactors or gravity tractors fare against something so massive and unpredictable? The answer lies in the kind of in-depth, real-world data only a close flyby campaign can deliver. There's also the tantalizing idea of turning a threat into an opportunity. If we truly understand the composition and structure of asteroids like Apophis, we could one day mine them for rare minerals, water, or even use them as stepping stones for deep space travel. But before that future arrives, Apophis is our test of science, engineering, and international will. For the viewer, this isn't just about distant space agencies squabbling over budgets. The Apophis flyby is a rare moment when humanity is united against a shared cosmic challenge. It's a reminder that, despite borders, we share one fragile world, equally exposed beneath the night sky. The decisions we make now, what to fund, how to collaborate, how quickly to move, shape not only the science we gain, but the security of future generations. So what can you do? First, stay informed. Support public investment in space science and planetary defense. These aren't luxuries. They're insurance for our world. When you hear of missions like Janus, OSIRIS-APEX, Ramses, or the next major asteroid survey, know that your curiosity and advocacy matter. Lawmakers and agencies respond to public interest, especially when it's loud, clear, and persistent. Second, consider the broader lesson. Humanity's real superpower isn't technology or rockets, it's cooperation. The same skills that can intercept a rogue space rock are those that solve global problems here on Earth. Climate change, pandemics, technological risks. The Apophis story is a live fire rehearsal for the kind of rapid cross-border action our future may depend on, again and again. And if you ever doubt that individuals and small groups can make a difference, remember this. Many of today's asteroid missions, from DART to OSIRIS-REx, began as proposals from a handful of passionate scientists. Public excitement and grassroots advocacy turned them from white papers into spacecraft. Your voice, your curiosity, really can push the needle. So, will humanity capture this never-to-be-repeated scientific opportunity, or will it slip through our fingers? Right now, the outcome is still in doubt. NASA's decision on Janus, ESA's funding for Ramses, and JAXA's final trajectory options for Destiny Plus hang in the balance. The scientific community is shouting with one voice. Time is running out, but not gone. In the next year, we'll know if the call was heard. If not, the world will watch as Apophis sails by, carrying secrets we failed to seize. But if we succeed, the data we gather could help safeguard our planet for generations. And here's the secret fact most haven't realized. Apophis's 2029 flyby will be so close, just 31,000 kilometers above Earth's surface, that it will actually pass beneath our geostationary satellites. For a few minutes, this cosmic interloper will be closer to us than some of our own TV satellites, a vivid reminder of the thin line separating us from the unpredictable universe beyond. If you're as fascinated by this once-in-a-lifetime event as we are, share this video, subscribe for updates on space missions, and let your representatives know you care about planetary defense. Humanity's next chapter